Hey, welcome back to the second part, managing OSPF priority and troubleshooting. Again, we're going to have some review here, but there's little pieces in between that you might not know, so I'll be brief so we can get to the exercises, because I know reading about show commands is not nearly as effective as doing them, but the trick is to be ready to do them. So I'll slide away and let's get to it so you can get to the labs. Establishing priority. Now we talked about BDR and DR. So setting up the priorities, that's a matter of just choosing the priority value is the one way, again. And then also remember doing the loopback address. But the IP OSPF priority with a value shot, that's one of the things we'll be practicing. Now, one thing that we talked about before is the idea of a default static route in OSPF version 2. These would go on something called the ASBR, or Autonomous System Boundary Router, because the autonomous system, you're at the edge of area 0, and inside area 0, when you configure OSPF, all of that routing table and routing traffic inside the area is going to be available to all the routers. But what about routers outside that area? If you create a default route inside OSPF, you want people to have it outside, you do the default information originate command. And that takes default route information, such as our quad 0 route here, and then it originates it inside here and injects it into the routing table to be put outside. And it comes out differently than the others. You see, we set the we have a static route on the inside, but from the outside it will have a little bit different loopback to it. Or pardon me, a little bit different look to it. So, gateway of last resort, and then we have static route with an asterisk. When you look at the table up here, you notice that down here we have S for static, but we also have EX, EIGR, pardon me, that's not the one I want. I wanted E2 OSPF external, OE2, external type 2, all right? And there's OE external type 1 as well. But this will show in how routes get pushed out, and we'll see them in routing tables, knowing if they originated from inside or outside the network. So that's the default originate command in IPv6. So, also, and this is kind of picking up a few things about OSPF we might not have heard about, the hellos have to match, because they have to say hello the same amount of time, and they have to wait the same amount of time and end out, because if the hellos don't match, they won't be communicating and the link will go down. So we can configure these timers here. The timers have a default, but you can go ahead and adjust them. So if hello is 10 seconds instead of 2. And then dead time, we'll say, okay, I haven't heard from them in 40 seconds, so this link is dead. And then in 40 seconds, we flush it out. Well, in this configuration, we've made the dead and wait time to be the same. Okay? So that's how the timers work. It's the hello packets, the background. We wouldn't see this unless we debugged IP OSPF. Okay? So, hello interval 5, dead interval 20. That's all you do. IPv6, hello interval, dead interval, etc. And then you've got it, and then it flushes out after that. That's timing. That's another way to manage traffic. If you have too much OSPF traffic in your neighborhood and your routers are pretty stable, you can take it down to a few seconds. So those routing updates, those hello packets are the updates. Now we can secure it. That can be so somebody coming into the network doesn't find a way in to come in and hack your processes. So we use the MD5 hash in authentication. Actually, there's 3 types. There's null, which is no authentication, and simple password authentication, which is about as good as null anymore because the password's in clear text. So if we want to authenticate in OSPF, we use MD5 authentication, Message Digest 5. And that is the method we touched on this before with the MD5 algorithm. So what happens is it sends a secret key with a signature, and if the signatures match on either end, then it accepts the authentication update. Once it establishes a connection and authenticates, it doesn't have to do it every time unless it's been taken down. But when it happens, you have to authenticate globally. You have to turn on MD5 globally because it's a process that runs outside the protocol. The router does the computing on it. And then once MD5 is running, you go into IP OSPF message digest key 5 and then put in a password in the interface config. And then the area ID authentication MD5 is the other end of that. Now, if you want to do it just on an interface, you can just do the MD5 in the interface configuration command. All right. So here's what that would look like. We'll be doing this in the lab. Area 0 authentication message digest, turns it on, you get out. Then you go into your interfaces. So in the router mode, you turn it on, and then you exit and go into interface mode and configure it per interface with the passwords. And this is going on getting the rest of the interfaces down. And to verify, just show IP OSPF serial interface. And then if they're all up and talking to each other, and then down here it tells us, right here, it says, yeah, message digest, oops, sorry. Back one more here. Apologies. And then right down here it tells us, look, message digest authentication enabled, youngest key ID is 1. All right, so that's how we know what's going on there. And this and that's just the rest of the output for the verification. But notice again, here are the types. E1 OSPF external, E2 type 2, and then down here we have this is showing that OSPF was learned through E2 external type 2 route, all right, subnet masks, etc. Now, forming adjacencies, with authentication, if they're not on the same network, they won't form, all right, and the network types have to match. And the hello and dead timers have to match. So if any of these things don't match that you see here, then it's not going to work. And authentication is probably the toughest one because things matter like uppercase, lowercase, little invisible spaces, etc. can be the difference between making it and not. So you have to be sure that you have your passwords correct. All right? So that's how adjacencies form, and when the adjacencies form, OSPF can go to work. All right. Now, when it's down, you establish neighbor adjacencies, figure out who you're talking to. That's where the DR, BDR come into play, and they're accepting LSAs from everybody. And then the init, you go into the init state and the two-way state. And once you're there, you have to move out. If you're in the two-way for extended periods of time, something's wrong. You have to go into you have to get to full state. Because during the X start and exchange, that's when they're synchronizing OSPF databases, converging so that every router understands the OSPF topology in the same way. That process has to complete, and then the routers move to a full state. And that's where you want to be. Start down, init, get the two-way, and once you've done the adjacencies, then you do the synchronization. That's the difference between two-way and full. Two-way means they're talking, but full means they understand each other. So these are the troubleshooting commands. We've seen a lot of these before, and I won't go through them all together, but remember show IP protocols and show IP OSPF. Putting the IP in front is always something people forget. But these limit your output to OSPF information and make it much easier to read. Now when you're troubleshooting OSPF, it's pretty straightforward. You make sure your interfaces are operational. And then if the interfaces, do they have OSPF on them? Are they in the same OSPF area? Is the interface configured as passive, because if it's passive, it's not going to get link state updates, etc. And then use your show commands. Show IP OSPF will tell you everything you need to know. Then, if you haven't got your neighbors up, that's where and a lot of times it's the debug IP OSPF with options as well. So, show IP route command tells you a lot about it as well. Remember, the routing table tells you more than just about anything you want to know. Show IP protocols. That tells you, helps you see what networks you're routing, which OSPF networks you have up. And if networks on OSPF, make sure that they match on all of the routers. All right, so the show IP route, show IP protocols again. Here's a final display of all of those. We're going to call it good after this. I don't think there's anything new here. And show IPv6 route OSPF. Remember to keep your IP and your IPv6 straight. Okay, so this should be enough to get you going. This is what we'll be doing in OSPF Chapter 5. It's a bit long, there's a bit more here, but it's kind of fun and interesting too. So I hope you enjoy the challenge. Bye-bye.